All right, we're going to get right into it. So we're going to continue off from our last lesson. In the last lesson, we talked about the three primary trig ratios, sine, cos, and tan. And we learned a quick little helpful memorization tool which told us when to use which primary trig ratio. That memorization tool was SO, CA, TOA. Okay? Now, we know that the purpose of these three primary trig ratios is to help us solve a triangle, which means find all the missing sides and angles. Now that is going to be the key to today's lesson. Our goal is to find all of the angles. We learned how to do all the sides yesterday. So let's go label our triangle again just for a little bit of extra practice. Imagine C is our reference angle. That means that the side opposite of C is going to be our opposite side, opposite. The side that is touching or directly next to C, this is going to be our adjacent. So we'll put A right there. And then finally, the side that's the longest side in the triangle and also the side that is opposite of the 90-degree angle, this is what we call the hypotenuse. All right, well, it's much better if you can spell that. Let's try, there we go. Hypotenuse, or just H. Now, when we do this, we're now going to apply our SOHCAHTOA memorization tool. So that means sine is the equivalent of the ratio opposite over hypotenuse. So sine of theta is equal to opposite over hypotenuse. Cosine is CA, adjacent over hypotenuse. And then finally, the adjacent over, or the opposite over adjacent, that's TOA. So that's tan of theta. So in this lesson, what we're going to do is we're going to be calculating for theta this time. So that means that we must already know the values in our trig ratio, the actual ratio itself. So how do we actually type that into our calculator? Because before we hit our trigonometric ratio and just followed it up with an angle. But what if it's the angle that I need? Well, in order to do this, on your calculator, you're typically going to have buttons directly above your sine, cos, and tan. You can see that they're labeled as sine of -1, sine to the power of -1, cos to the power of -1, and tan to the power of -1. We call these the inverse trigonometric ratios, inverse. Okay? Now, this is actually a bit of bad notation, okay? Because whenever we have a value to what looks like a negative exponent, so let's say I have a value of x to the -2, that can actually be written as 1 over x to the power of 2. If I have x to the power of -1, that could be written as 1 over x, because the 1 would be the power here. Now, we're seeing it here like sine to the, let me just back that up, sine -1. So that leads us to believe this must be the same as saying 1 over sine. But that's actually not the case. You will not get the correct results. So this is why this notation of sine -1 is a bad notation. Okay. Now, for simplicity purposes, most of us just call it the inverse trig ratio. So inverse sine, inverse cos, or inverse tan. Or sometimes you might just say tan inverse tan cos, or tan inverse tan cos, or inverse sine, inverse cos, or inverse tan. But that's not actually accurate. It's not correct. So instead, the proper name for these things is not, we don't say sine inverse or inverse sine. What we say is arc sine. This is the proper name for it, or arc cos, or arc tan. So these are technically the correct names for these things. And they have nothing to do with this. This is wrong. It is not accurate. Okay? That is something that will come up later on and have different names, and it's not in this course. Wait for grade 11 for that stuff. Okay? So let's get back to what we were trying to do. we still want to be able to find the angle. And in order to find the angle, we are going to have to use these buttons. Now on your calculator, they'll be above your normal buttons. I doubt they're going to have their own buttons. So typically they're going to be above. And you'll notice in this picture here that they're the color blue. That means somewhere on that calculator, there'll be a button that is also blue that allows you to access all those hidden operations above the buttons. So usually it's a button that has the word function on it or the word shift or something like that. And it'll be the same color as the labels above that one. So you'll hit that button to access those ones. Okay. If you have an iPhone or an Android phone, you'll see that written directly in there. I wish I could show you on my screen right now. I have an Android phone, and when I hit the inverse button, it calls them arc sine, arc cos, and arc tan. It doesn't call them inverse sine or anything like that. Okay, so let's figure out how we actually do this. So imagine we have this first example, tan A equals 4 over 3. So how does this work? So this is how we rewrite this. We're going to take the angle. We're trying to find the angle A. And that's going to be equal to the tan inverse, even though it's not really, the tan inverse of 4 over 3. So when you type it into your calculator, depending on how your calculator works, you might have to do the 4 over 3 first, or you might have to do the tan inverse first. You have to experiment with your calculator. So for example, on the Windows calculator, let me see if I can pull it up from my screen. On the inverse calculator, or sorry, the Windows calculator, I actually have to do the 4 divided by 3 first. And that's going to give me 1.333 repeated. And then I choose the arc sine operation, and we end up with a value of, you should end up with a value of approximately 53 degrees. Okay, now this is to the nearest degree, as it says here. To the nearest degree. Okay. So you should end up with A is approximately 53. If you don't get 53, make sure that your calculator is in degree mode. Okay, you should end up with approximately 53. Let me just check something on my calculator real quick. Make sure I am getting the numbers I want. Pop. Yes. There we go. Alrighty. Okay, so we're going to continue now. In this next one, it's the same process. We're going to take the angle. So the angle we're looking for is B. B is going to be equal to the inverse of our trig ratio here. So cos inverse of 0.265. Now, when you plug that in, you should end up with an angle of approximately 75 degrees. Now we go to the next one. Same idea. This one's a sine. So we have C is equal to sine inverse of 0.7071. And you get a value of C is equal to approximately 45 degrees. Okay. And then we have one last one here. You can see the operation is the same thing every time. Take the angle, and that's going to be equal to the inverse of your trig operation. So in this case, sine inverse and 1.25. And in this case, we're going to get a value of not possible. What? How could we possibly get a not possible? How is that a thing? Well, what does that mean? Well, think about what sine means. That means that sine is the opposite over hypotenuse, and we're getting a value of 1.25. What it's telling us is that there's no angle that will result in a value of 1.25 for sine. It's just not a thing. And how do we know this? How is this possible? Well, because remember what we said about sine. It's impossible for us to get a value greater than 1 in this situation, right? We can't actually do that. So in any case, there is no way for you to get this. So if you type this into your calculator, let me just type it into my calculator and I'll read you the exact operation I get, or the exact result I get. This is on my Android phone. So don't make fun of me. It's actually a Google Pixel. So don't phone shame me. All right. I get 1.25 and I get domain error. Domain error. It means it's physically impossible to actually calculate. Boo. Your calculator may give a different operation, such as error or something like that. It depends on your calculator. But you will get some form of readout that says that is not a possible operation to do. So we say not possible. No possible? No possible value. How about that? No possible value. There's no possible angle that makes this true. Okay? Alrighty. So let's go down. Let me just go back up here. You saw the same. This was the same operation for what we saw yesterday with the cosine. It's the same thing because the adjacent is smaller than the hypotenuse, which means we could never have a value of greater than 1. It's just not possible. Can't do it. Okay. And the same thing goes for sine because the hypotenuse is on the bottom of that one too. So this one, now we're actually going to do it on some triangles. Find the measure of angle A and round to the nearest angle. And is it always going to be angle A in every question we ever do? No, but it is in these examples because it just makes the question asking easier. So we're trying to find angle A here, we're trying to find angle A here, we're trying to find angle A here, and we're trying to find angle A here. So for each one of these, let's start off by labeling our triangle in terms of opposite, adjacent, hypotenuse, okay? So opposite is always opposite of our reference angle. So this is going to be opposite. The hypotenuse is always the one across from the 90, which means this is the adjacent. Let's do it in all of them while we're sitting here. So our opposite, our adjacent, and our hypotenuse. Our opposite, our adjacent, and our hypotenuse. And our opposite, our adjacent, and our hypotenuse. So we have all of our triangles labeled. Now it's just a matter of deciding which operation we're going to be using. Remember, we're trying to find the angle. So that means I need data for two sides to make this work. Well, in this one, we have 10, which is A, and we have 14.9, which is H. AH, that tells me that it is ka. Remember, so ka toa. So this one is going to be ka. Okay, so let's fill out the data. So that means we have cos of A is going to be equal to opposite, which is, or sorry, not opposite, adjacent, which is 10, over hypotenuse, which is 14.9. So A is going to be equal to cos inverse of 10 over 14.9. And when you do this, you should get a value of A is approximately equal to, now this is to the nearest angle, so the nearest degree, this is going to be 48 degrees. Okay, let's do it again. So what's on this one? So this one we have opposite and we have adjacent. So that is TOA. That means tangent. So we have tan of our angle A is equal to our opposite, which is 11, over our adjacent, which is 8. So that means A is equal to tan inverse of 11 over 8. A is going to be equal to approximately 54 degrees. Okay, keep going. What else we got here? We got two more. So what sides do we know? We know opposite and we know hypotenuse. OH, that's sine, so. So that means we have sine of A is equal to our opposite, which is 17, over our hypotenuse, which is 50. So that means A is equal to sine inverse of 17 over 50. And you get a value of A is approximately equal to 20 degrees. One more. So what do we have? We need two sides here. We need opposite, which is 8, and hypotenuse, which is 9. So we have OH again. So that's sine again. So we have sine of angle A is equal to our opposite, which is 8, over our hypotenuse, which is 9. And we end up with A is equal to sine inverse of 8 over 9. And you end up with a whopping A is equal to approximately 63 degrees. Make that a little more obvious. That's all there really is to it until we start entering into word problems and such. But it's still really the same idea. So let's try and draw a picture before we can answer any of these questions. A ladder, which is 4.3 meters long, is used to reach 2.2 meters up a tree. That implies that the tree is taller than that. So if we have a tree, let's say this big long stick is the tree, okay? And we have a ladder leaning up against this tree. It tells us that the ladder is 4.3 meters long. It tells us that it hits the tree up here 2.2 meters up the tree. Okay. What angle does the base of the ladder make with the ground? So it wants to know this angle down here. So let's label our triangle. So let's label this as A, B, and C. That means I'm trying to solve for angle C. So if this is our reference angle, that means the 2.2 is our opposite. This means this is the adjacent and this is the hypotenuse. So again, what sides do we have? We have opposite and we have hypotenuse. That implies sine again. So we have sine of, let me just update this. There we go. We have sine of C is going to be equal to our opposite, which is 2.2, over our hypotenuse, which is 4.3. So that means C is equal to sine inverse of 2.2 over 4.3. And you're going to end up with a lovely C is approximately equal to 31 degrees. Okay? So therefore, the angle made with the ground is 31 degrees. Great. Let's go do another one. Same idea. Okay. Oh, clicking a little too far there. Let's just see how far we need to go here. There we go. Alrighty. So, a support wire securing a 4.2 meter pole is tied to the ground 2.5 meters away from the base. So the pole is 4.2 meters. So here's our pole, and that thing is 4.2 meters. And there is a wire tied to it, right, like so. And it is tied to it on the ground 2.5 meters from the base of the pole. So that's telling me this distance is 2.5. I have no idea how long the actual wire is, nor do I need to know. But I know that the ground and the pole are going to create a right angle. Okay. What angle does the support wire make with the ground? So again, it wants to know this. So let's not even label the triangle this time. Let's just label the angle as theta, which is a very common thing to do in these types of problems because we don't actually care about all the vertex names or anything like that. In this question, we just care about the angle. So let's say let theta be the angle between the wire and the ground. There we go. Okay, so we got to look at what we know relative to this angle. So that we have to label the triangle. I'll go to red here for a second. That means the side opposite is the opposite. The side touching it is the adjacent. And then, of course, we have the hypotenuse. So what do we got and what do we need? Well, we have the opposite. We have the adjacent. So we have OA, SOHCAHTOA. Oh, that's tangent. That is tangent. Okay, so that means tan of angle theta is going to be equal to opposite, which is 4.2, divided by adjacent, which is 2.5. Okay, so what happens when we do this? We got to solve for theta. So that means theta is going to be equal to tan inverse of this value, 4.2 divided by 2.5. So we end up with an angle for theta of approximately 59 degrees. And that's all the question was asking for. So we just need a concluding statement. Therefore, the angle of the wire and, the angle between the wire and the ground is 59 degrees. There we go. All right, next question. Solve for x and y and angle y. So solve for side x, and angle y. That's what we're looking for here. side x, and angle y. So I'd love to solve for y, except the problem is I need 2 side lengths, and I don't have 2 side lengths. However, since x is a shared side, if I calculate for x first, that means I can calculate for y. Now, since I'm solving for a side x, that means I don't need to do the inverse methodology. I just use a regular trig ratio. So which ones do we have? What do we got here? Do we know anything? Well, we know that the angle up top here is 35 degrees. So if I treat that as my reference angle and I label my triangle, that makes this opposite, it makes this adjacent, and it makes the 19 the hypotenuse. So that means we are looking for adjacent and we have hypotenuse. So AH, SOHCAHTOA. Oh, it's cosine. Cosine. So what do we got? We got cos of 35 is going to be equal to our adjacent, which is x. Hey, that's what we're looking for. Over our hypotenuse, which is 19. So now we just need to solve for x. We cross multiply, and we end up with 19 cos 35 is equal to x. So x is going to be approximately equal to 15.6 meters because it's the nearest tenth. So 15.6 meters. So now that I know the value of x, that means I have 2 sides for this triangle. So I can now calculate for the angle y. So what are these? So again, I need to label it in terms of reference. So in this case, the x is now the opposite side. And below here is the adjacent. And we have the hypotenuse up here as usual. So that means that we have the opposite. We're looking for the angle y. We have the hypotenuse. So we have O and H. O and H. So that's SOHCAHTOA. So sine of our reference angle, which is, oh wait, that's what we're trying to find. Yay. Equals opposite, which is x, 15.6, divided by 16.5. Our hypotenuse. Okay? And when you do this, you're going to end up y is equal to sine inverse of 15.6 over 16.5. And we end up with y is approximately equal to 71 degrees. Okay? And this is not a word problem, so I don't need a therefore statement or anything like that. I just got to make sure my answers are boxed. Okay, we're almost done. A couple communication questions here. Is it possible for an unknown angle in a right triangle to be greater than 90 degrees? So think about what it's saying here. We have a right triangle, and the only value we know is that right triangle. Is it possible that either one of these angles, either this angle or this angle, are greater than 90 degrees? The answer is no. And the reason being is that the 90 degree, remember there's only 180 degrees in a triangle. That means that the 90 degrees has to be the largest angle because the other two have to add up to the other 90. So you can't have an angle of 0 degrees. So that means that they have to be less than 90 degrees. So the answer is no. Since all angles in a triangle add up to 180, all triangle angles add to be 180, add to 180 degrees. And there is a 90 degree angle, and there is a 90 degree angle. The remaining angles must be less than 90 degrees. Oops. Must be less than 90 degrees. Awesome. So, our primary trig ratios, just as a reminder, our primary trig ratios, SOHCAHTOA, can only be used with right triangles. But oh no, what if we don't have a right triangle? Is it still possible to find the angles and sides? Well, it certainly isn't with these primary trig ratios. We can't do it. We need a right angle. But that doesn't mean it's impossible. So the next two lessons are going to help guide us through that process, calculating sides and angles for a triangle that is not a right angle triangle. Okay? And that is the purpose of those next couple up and coming lessons. And that's it for now. Almost done.